Hello everyone, good day. This is Binatao Daina, a student from Bachelor of Secondary Education, major in Mathematics. At the end of this video presentation, you will be able to learn how to solve integrals using the technique of integration by parts. Second, you will learn how to solve the solid of revolution using the disk and washer method. For our instruction number 1, among the 4 techniques, integration by parts, and trigonometric integrals, trigonometric substitutions, partial fractions, choose one of the techniques and discuss the solve integrals. For our first problem, find the integral of x cubed over the quantity of x squared plus 2 squared dx. It can be computed using 3 different methods: substitution, partial fraction, or integral by parts. But I will use the integration by parts. First, we let the first derivative of x is equal to x over the quantity of x squared plus 2 squared dx, and g of x is equal to x squared. To compute of f, we need to integrate x over the quantity of x squared plus 2 squared using the substitution. We let u is equal to x squared plus 2, du is equal to 2x dx, and dx is equal to du over 2x. When we substitute the values of u, du, and dx, the integral of x over the quantity of x squared plus 2 squared dx is equal to the integral of x over u squared times du over 2x. Using the constant rule, we put 1/2 outside the integral of 1 over u squared times du. To simplify, we have 1/2 times negative 1 over u plus c, which is our c is the constant. Now our final answer will be negative 1 over 2 times x squared plus 2 plus c. Therefore, if the first derivative of x is equal to x over times the quantity x squared plus 2 squared, then f of x is equal to negative 1 over 2 times x squared plus 2. Then, we can write f of x is equal to negative 1 over 2 times x squared plus 2, which is the first derivative of x is equal to x over x squared plus 2 squared. And g of x is equal to x squared, and the first derivative of g of x is equal to 2x. Using the following formula, the integral of the first derivative of fg is equal to fg minus integral of f, the first derivative of g becomes integral of x over x squared plus 2 squared. X squared dx is equal to negative 1 over 2 times x squared plus 2x squared minus the integral of negative 1 over 2 times x squared plus 2x dx. And by simplifying further the equation or problem, so we have the integral of x over x squared plus 2 squared x squared dx is equal to negative 1 over 2 times x squared plus 2 x squared minus the integral of negative 1 over 2 times x squared plus 2x dx is exactly equal to negative x over 2 times x squared plus 2 plus the integral of x over x squared plus 2 dx. We need to remember that this second integral can be computed using the same substitution. So we let w is equal to x squared plus 2, dw is 2x dx, and dx is equal to dw over 2x. We have the integral of x over x squared plus 2 dx is equal to the integral of x over w times dw over 2 dx. And by following the constant rule again, we have put 1/2 outside the integral of 1 over w dw, which is exactly 1/2 ln absolute value of w plus c. Remember that c is our constant. Without further ado, our final answer is 1/2 ln times x squared plus 2 plus c. So, The entire integral will be integral of x cubed over x squared plus 2 squared dx is equal to negative x squared over 2 times x squared plus 2 plus the integral of x over x squared plus 2 dx, which is exactly as negative x squared over 2 times x squared plus 2 plus 1 half ln times x squared plus 2 plus c. Okay? That is for our first problem using the integration techniques. Let's proceed to the second problem. For instruction number 2, define your function and describe them by graphing the function and the area bounded by that function. Formulate a problem that involves finding the volume of the solid of revolution using A. Disk method and B. Washer method. For problem number 2, find the volume of the solid generated by revolving the region bounded on the left by the parabola x is equal to y squared plus 1 and on the right by the line x is equal to 5 about A, the line x is equal to 5 and B, the y-axis. Let us consider that the solid generated by revolving a region bounded on the left by the parabola x is equal to 5 the y squared plus 1 and on the right by the line x is equal to 5. The graph of the curve is given in the figure. Now we find the volume of the solid of revolution revolve about the line x is equal to 5 by the disk method. If the outer radius is equal to 5 minus y squared plus 1 is equal to 4 minus y squared, the volume by disk method is the integral of pi, the outer radius of 2 dy. Using substitution, we have the value of the outer radius integral of pi 4 minus y squared dy is equal to pi integral of 16 minus 8 y squared plus y to the 4th dy by following in constant rule is equal to pi 16y minus 8y to the 3rd over 3 plus y to the 5th over 5 to the limits of 2 and negative 2. That is equal to 2 pi 32 minus 64 over 3 plus 32 over 5. So now we integrate using the power rule of integration. The integral of pi for y squared dy is equal to pi's integral of 16 minus 8 y squared plus y to the 4th dy is equal to pi 16y minus 8 y to the 3rd over 3 plus y to the 5th over 5 to the limits of 2 and negative 2, and by substituting 2 and negative 2 we get 2 pi 32 is minus 64 over 3 plus 32 over 5. By multiplying 2 by 32, we have 64 pi times 1 minus 2/3 plus 1/5 is equal to 64 pi over 15 times 15 minus 10 plus 3, which is simplified our answer we got. The volume is equal to 512 pi over 15. We have here, we can see the graph of the disk formed by the line x is equal to 5 and the two graphs. Now for washer method, if the region we revolve to generate a solid does not border in a cross axis of revolution, the solid has a hole in it. The cross section perpendicular to the axis of revolution are washers instead of disk. Now the washer's area is equal to pi the outer radius squared minus pi the inner radius squared, where r of x is the outer radius and r of x is the inner radius. Volume by the washers for rotation about the x-axis is given as integral of a of x dx is equal to the integral of pi the outer radius minus the inner radius squared dx. Now we need to find the volume of solid generated by revolving about the y-axis. In this case, the outer radius is equal to 5. The inner radius is y squared plus 1. So from the previous equation, we get the volume by Washer's method is V volume is equal to the integral of pi times the outer radius squared minus the inner radius squared dy is equal to pi integral of 25 minus y squared plus 1 squared dy and is equal to pi integral of 25 minus y to the fourth minus 2y squared minus 1 dy. To simplify, we get pi integral of 24 minus y to the fourth minus 2y squared dy. That is equal to pi 24y minus y to the fifth over 5 minus 2y to the third over 3 to the limits of 2 and negative 2, and is exactly as 2 pi times 24 times 2 minus 32 over 5 minus 2 over 3 times 8. By that we get 32 pi times 3 minus 2 over 5 minus 1/3 is equal to 32 pi over 15 times 45 minus 6 minus 5, and is exactly our answer is 1088 pi over 15. That will be our answer for the second problem. I hope you've learned something from this video presentation. Again, this is Daina Binatao. Thank you for watching.